Okay, in this section we're looking at multiplying and dividing rational expressions. Same rules apply as when we multiplied and divided regular fractions. You still do the same steps. The only difference, remember now, is with rational expressions, you have variables thrown in there. So for the warm-up, we're just going to start with regular fractions. So if I have -3/4 times 1/2, but check and see, is there anything I can reduce before I multiply? And there isn't, so then I multiply numerator by numerator and denominator by denominator. So I have 3 times 1 is 3, -4 times 2 is -8, and we never put our negative in the denominator. We either put it in front of the fraction or in the numerator. For b, I have 5/8 times -4/15. Well, my 5 and my 15 can reduce. I divide 5 into each of those. And -4 and 8, I can reduce those. So I'm left with -1 times 1 and 2 times 3 on the bottom, so I have -1/6. C, I'm dividing with fractions, and when you divide with fractions, you of course take and flip the second fraction and change your divide to multiply, and we usually just refer to it as multiplying by the reciprocal. And then you do the same thing. You check if you can cancel anything or simplify, and if you can't, then you just multiply. So I have 8/9. Example D, that is still a division question. I have 2/5 over -1/10. So this, if I rewrote it, is the same as saying 2/5 divided by -1/10. So same rules apply. I multiply by the reciprocal. I reduce where I can. 5 goes into 5 once and into 10 2 times. So I have 2 times 2 is 4 over 1 times 1, which is just 1. So my fraction there would just be a 4. And I dropped my negative here accidentally, so it should be a -4. So to multiply fractions, the steps we used were, first of all, we reduce where we can. Then we multiplied numerators. And then we multiplied denominators. And then, if it was possible or necessary, we reduced again. Our steps for dividing then were, we would multiply by the reciprocal. So we would flip the second fraction. And change our operation to multiply. So multiply by the reciprocal. Pretty sure I spelled reciprocal wrong. Then we reduced, if you can. Then we multiply numerators, multiply denominators, and then of course we reduced again if we needed to. Okay, you always want your answer in simplest form. And if you simplify before you do all that, then you've got much smaller numbers to work with. Okay, so when we're working with rationals, it's the same steps, but because it's a rational, that means we can have a variable in the numerator and in the denominator. And if there's a variable in the denominator, then we have to look for our restrictions or our non-permissible values. So in example A, my denominators for this one are constants. There are 2 and a 4. So because they're constants, I know there aren't any restrictions. There's no value that I'm going to be substituting into the denominator, so I don't have to look for a restriction. So I simply then just multiply. So this one's going to be a straightforward numerator times numerator and denominator times denominator. So in the top here, if I just look at my numerator, I have a binomial times a binomial, so that means I'm going to have to FOIL. So I'm going to have x squared plus x plus 3x plus 3. Multiply my denominators, 2 times 4 is 8. So I have x squared plus 4x plus 3 all over 8. And there's nothing I can reduce there. Remember, you have to be able to reduce the whole polynomial, not just parts. So I can't reduce my 4 and my 8. Okay, in example B, I have variables in my denominator, so I need to take those variables, put them not equal to 0, and solve. So for my 2, I don't worry about my 3 and my 8 here because they're constant, so I know I don't have to worry about them not equaling 0. But I have to take my variables. So I have an x, that's not equal to 0, and then I also have a y in this case. So those are my restrictions. I didn't have to do any solving for them, they're just by themselves, so that's good enough. So now to do the actual work. First thing I look for is, can I reduce anything? So if I look at numbers, my 4 and my 8 will cancel, so I'm left with 2 there. That canceled to leave me with 1. I have an x here in the denominator, so that's going to cancel out one of those, but I also have an x here, so that's going to cancel that one completely. The y and a y squared will cancel to leave me with a y. So if I look at what I'm left with here, I have a 1 over 3, and my other fraction, I have a y over 2. So my final answer is going to be y over 6, with my restrictions of x is not equal to 0, y is not equal to 0, and my final answer of y is y over 6. Example C. So I have to take my denominators first of all to find my restrictions. So I have 2 pi r in that denominator, so that means I have pi is not equal to 0 and r is not equal to 0. In my second denominator, I have d minus 2, so if I set that not equal to 0, d is not equal to 2. So my restrictions are going to be d is not equal to 2, pi is not equal to 0, and r is not equal to 0. So remember, you always identify them as your NPVs, and then you're done. So now that you've done that, you can do whatever reducing you can. So starting here, my 2 and my 2 will cancel each other. My pi and my pi can cancel. My r and my r can cancel. Now I have to remember, I have a d here in the denominator here, and there is a d down here, but I can't cancel those because my d minus 2 go together. It's a polynomial. If I can't cancel the whole thing, I can't cancel anything. So what I'm left with then is a d over 1 times h over d minus 2. So what I have is dh over d minus 2. This middle step that I wrote in here, where I basically just rewrite what I'm left with, you don't have to do that. You can just leave it as it is with your canceling and then go straight to your answer. But if it helps you to keep things sorted out in your mind, then rewrite it. Okay. When you're given polynomials and they look like these ones here, the first thing that you always want to do is see, okay, can I factor any of these so that I can do some canceling after I found my restrictions. So in A here, I have y squared and minus 9. So I have two terms, they're both perfect squares, and they have a subtract, so I know then I've got a case of a, I'm just going to start over here, of a difference of squares. So I have y minus 3 times y plus 3. On the bottom, I have an r in both of my terms, so I can GCF an r, which leaves me with r squared minus 1. I'm multiplying that to r squared minus r, so I can GCF an r to have r minus 1 and a y plus 3. So before I do any canceling here, I'm going to see, can I go any further? Well, in this first denominator, I have another difference of squares. So that means I have y minus 3 times y plus 3 over r times r minus 1 times r plus 1 times r minus 1 over y plus 3. So before I go to my canceling, I do my restrictions. So I take each factor in the denominator and I come up with my restrictions. So I have an r not equal to 0. That one is solved. I have r minus 1 is not equal to 0, so that means r can't equal 1. I have an r plus 1 not equal to 0, so that means r can't equal negative 1. And I have y plus 3 not equal to 0, so y can't equal negative 3. So my restrictions altogether are going to be r not equal to, where am I, negative 1, 0, and 1, along with y not equal to negative 3. So you have a few restrictions for that one. Okay, so now I have my restrictions. I can do my canceling. So on the top here, I have a y plus 3, and I also have a y plus 3 in the denominator there. So remember, you can only cancel from top to bottom. You can't cancel if they're beside each other. I have an r down here, which will cancel that r up there, and an r minus 1 will cancel that r minus 1. So once I'm done all my canceling, I can see I'm left with a y minus 3 on the top and an r plus 1 on the bottom. So that is my simplified equation with my restrictions. Example B, x squared minus x minus 12. So to simplify this one, I know it's a product and sum, where my product is going to equal negative 12, and my sum is going to equal negative 1. So that leaves me with a negative 4 and a 3. So I have x minus 4 times x plus 3 on the top. On the bottom, x squared minus 9, that's the difference of squares, so I have x minus 3 times x plus 3. On my second rational there, I have x squared minus 4x plus 3, so I'll product and sum. Product of 3, sum of negative 4, so that's going to be a negative 3 and a negative 1. So I have x minus 3 times x minus 1. In the bottom one there, I can GCF an x. So I'm just going to do this one on the side. So I have x times x squared minus 4. That's the difference of squares. So I have x times x minus 2 times x plus 2. Okay, so now I have my list of factors. I need my restrictions. So I have an x minus 3 not equal to 0. So x is not equal to negative 3. I have x plus 3 not equal to 0. So x is not equal to negative 3. Sorry, that first one should have been a positive 3. I have an x not equal to 0. X minus 2 not equal to 0. So x can't equal 2. And I have x plus 2 not equal to 0. So x can't equal negative 2. So my list of restrictions, x cannot equal negative 3, negative 2, 0, 2, oh, I'm going to run out of room there, and 3. So those are restrictions. So now I can go to my canceling. Only cancel top to bottom. So x minus 3 and x minus 3, x plus 3 and x plus 3. And that's it. I can't get rid of anything else that I can see. Oh, I made a mistake. Up here, when I did my x times x squared minus 4, when I take that out, it should have just been an x. So this isn't a difference of square here. Oh, I'm going to have to do a couple of changes. Sorry about that. X, this should have been x times x minus 4. So that's going to change my restrictions. I'll finish doing the canceling, then I'll fix my restrictions. So my x minus 4 and my x minus 4 are going to cancel. So I'm left with x minus 1 over x. So on my restrictions here, I didn't need x minus 2 and x plus 2, but I do need to add x minus 4 not equal to 0, so x can't equal 4. So my NPV should be x is not equal to negative 3, 0, and 4. 1 and positive 3. So I'll put a plus or minus 3, 0, and 4. Okay, the next example, same idea. I need to factor first, and once I've factored them, then I will flip them, find the restrictions, and divide. Or sorry, reduce, I guess, and then multiply. So first I'm going to do my factoring. So m squared minus 6m minus 7, that's a product and sum. So product of negative 7, sum of negative 6, so negative 7 and a positive 1. So m minus 7 times m plus 1. On the bottom I have a difference of square, so m plus 7 times m minus 7. And then I have another product and sum. So I have a product of 7. I'm going to run out of room here, and a sum of 8. So that's just going to be a 7 and a 1. So m plus 7 times m plus 1. Oops. And then the bottom, by GCF, I have m times m plus 7. So if I'm looking at my numerators here, when I do my restriction, and you have to be careful because you also have to do the flip restriction. Let me see. So my NPV, if I have m plus 7 is not equal to 0, then that means m is not equal to negative 7. M minus 7 is not equal to 0, so that means m is not equal to 7. I have m not equal to 0, and then I have another m plus 7 not equal to 0. When I do my flip, I have m, where am I? M plus 7 times m minus 7 on the bottom, times m times m plus 7 on the top, and m plus 7 times m plus 1. So I don't have my m plus 1, so I have to include that in my restriction. So I need to put m plus 1 not equal to 0. So m is not equal to negative 1. So all of my restrictions together are going to be m is not equal to, I have a negative 7 and a positive 7, so plus or minus 7. I had a 0 and a negative 1. So now I've done my restrictions, I can do my cancel. So I can only cancel top to top, bottom to bottom. So m minus 7 and m minus 7, m plus 7 and m plus 7, m plus 1 and m plus 1. So on the top I'm left with an m, and on the bottom m plus 7. Okay, the last one. This one has a combination. It's got a divide and a multiply. So always start with your factoring. So I have 3 times x plus 4 on the top, 3x squared minus 5x minus 12. So for that one, I'll do that over here. I'm going to do slide and divide, so that's x squared minus 5x minus 36. So I'm looking for a product equal to negative 36 and a sum equal to negative 5. So negative 9 and 4 will work. So I have x minus 9, x plus 4. So now I have to divide back through by that 3. So I divide 3, divide 3. So I have x minus 3, x plus 4 thirds. Whoops, can't have a fraction, so I have to multiply by a 3. X minus 3 times 3x plus 4. So those are the factors for that one. X minus 3 times 3x plus 4. I'm dividing that by 12 over 3x plus 4, which can't be factored, and I'm timesing that by 2 times x minus 3 over x plus 4. So now I do my restrictions. So I have x minus 3 is not equal to 0, so x is not equal to 3. 3x plus 4 is not equal to 0, so 3x is not equal to negative 4, divide by 3. So x can't equal negative 4 thirds. I have another 3x plus 4, now I need an x plus 3. Or sorry, x plus 4. Not equal to 0, so x is not equal to negative 4. So now I can do my flip for that second one. 3 times x plus 4 times x, or over, sorry, divided by x minus 3 times 3x plus 4 times 3x plus 4 over 12. And then times 2 times x minus 3 over x plus 4. So at my flip here, I haven't changed, or I haven't added any other restriction because this 12 is a constant, so it's not going to change anything for me. So I'll finish my restrictions. So my restrictions are x is not equal to negative 4/3, negative 4, or 3. Now I can finish my cancel. So I have this 3x plus 4 and that 3x plus 4, x plus 4 and an x plus 4, x minus 3 and an x minus 3. Now I have a constant here of 3, so that'll go into there once and into 12 4 times. And then I have a 2, which goes into there once and into 4 twice. So on the top, I've got a 1, and a 1, so that means I've got 1 on the top. I have 1 times 1 times 2 times 1 on the bottom, so I have a 2. And that's just something to remember when people cancel out. They forget that what you're doing is you're left with a 1, right? You always need a placeholder for that. So you can't think of it as being a 0 because then that makes your answer in the denominator a 0. So you have your assignment there, page 327, number 1 AC, 2 AC, 8 ACD, 9, 11 C, 12, 19 AB, and 23. We'll work on those in class. See you tomorrow.